Classification of signals. Learning objective to deal different types of signals with properties. Learning outcomes. Learners are able to classify different types of signals. Basically, there are two types of signals, continuous time and discrete time signal. Continuous time signal is one in which both independent variable, that is time, and dependent variable, that is amplitude, are continuous in nature, whereas in discrete time signal, independent variable, that is time, is discrete in nature, and the dependent variable, that is the amplitude, is continuous in nature. In digital signal is one in which both independent and dependent variables are discrete in nature. Here the figure A shows the continuous time signal. Here the independent and dependent both variables are continuous in nature. And figure B shows the corresponding discrete time signal. Here only the independent variable is discretized. This is independent variable only discrete in nature, whereas the amplitude is continuous in nature. Classification of continuous time and discrete time signal. Deterministic and random signal, even and odd signal, periodic and aperiodic signal, energy and power signal, causal, non-causal and anti-causal signal. We will see one by one. Deterministic and random signal. Deterministic signals are functions that are completely specified in time. The nature and amplitude of such a signal at any time is determined. For example, in continuous time signal, x of t is equal to t squared by 1 plus at, where t varies from minus infinite to plus infinite and a is a constant. Here, at any instant of time, the signal x of t can be determined. For dt signal, x of n is equal to n by 1 plus n squared, where n varies from minus infinite to plus infinite. Here, for any instance, x of n can also be determined. So, any signal, we can say any signal which can be mathematically modeled can be under the category of deterministic signal. Then random signal. All non-deterministic signals are random signal. The nature of the signal at any time or any instant cannot be determined. For example, all noises are under random signal. Even and odd signal. If a signal exhibits symmetry in the time domain, then the signal is an even signal. All even signal satisfy the condition, that is x of t is equal to x of minus t for ct signal and x of n is equal to x of minus n for dt signal. If a signal exhibits antisymmetry in the time domain, then the signal is odd signal. All odd signals satisfy the condition x of t is equal to minus of x of minus t for ct signal and x of n is equal to minus of x of minus n for dt signal. Here figure A shows the example for even signal and figure B gives the odd signal. Any signal x of t or x of n can be expressed as a sum of its even and odd parts, such as x of t is equal to xc of t or plus xo of t, or x of n is equal to xc of n plus xo of n. Or we can say that every signal is composed of the addition of an even part and odd part. The even and odd parts of a signal can be derived from the signal itself by using the formula for CT signal. X e of t, that is the even part of the signal, is equal to x of t plus x of minus t by 2, and the odd part of the signal x o of t is equal to x of t minus x of minus t by 2. The same thing for dt signal. Even part of the signal x e of n is equal to x of n plus x of minus n by 2, and odd part of the signal x of n is equal to x of n minus x of minus n by 2. So if even and odd parts of the signals are given, we can construct the signal x of t as a sum of these two. If x of t is given, we can extract the even and odd part of the signal by using these two formulas. Good to know here is even and odd signals are mutually exclusive signals. Multiplication of two even signals resultant an even signal. Multiplication of two odd signals resultant an even signal. Multiplication of an even signal with an odd signal resultant an odd signal. Integration or summation of an odd signal gives zero value. Integration or summation of an even signal gives a non-zero value. Periodic and aperiodic signal. If the signal is repeated with a particular time interval, then the signal is a periodic signal. All periodic signals satisfy the condition, that is, for CT signal, x of t is equal to x of t plus t naught, where t varies from minus infinite to plus infinite. And for dt signal, x of n is equal to x of n plus n naught, where n varies from minus infinite to plus infinite. Here, t naught is the fundamental period for CT signal and n naught is the fundamental period for the dt signal. The sum of two or more periodic signals may or may not be periodic. If the ratio of their fundamental period is the rational, then the resultant signal is periodic, otherwise aperiodic. Signals that doesn't satisfy the above two conditions is aperiodic signal. Singularity function is a special case of aperiodic signal. Here, the figure shows this periodic signal and aperiodic signal for CT signal as well as for DT signal. Here, good to know here is a signal x of t is a linear combination of x1 of t with the fundamental period t1 and x2 of t with the fundamental period t2. Then if t1 by t2 is equal to a rational number, then you can say that x of t is periodic with the fundamental period t is equal to LCM of t1 comma t2, else aperiodic. Similarly, for dt signal, x of n is a linear combination of x1 of n with the fundamental period of m and x2 of n with the fundamental period of n. Then m by n is equal to a rational function. Then x of t is periodic with the fundamental period t is equal to LCM of m comma n, else aperiodic. Energy and power signal. Signal that are having finite energy and zero average power are called energy signal. That is, energy is finite. That is, E is equal to greater than 0, less than infinite, and P is equal to 0. Where E is calculated by using the formula limit of t naught tends to infinite integral x of t mod square dt. For dt signal, it is limit of n naught tends to infinite summation n is equal to minus n naught to plus n naught x of n mod square. And power, average power, P is equal to limit of t naught tends to infinite 1 by 2 t naught integral minus t naught to plus t naught x of t mod square dt watts for CT signal. And average power for DT signal, it is limit of n naught tends to infinite 1 by 2 n naught summation n is equal to minus n naught to n naught x of n mod square. Signal that are having infinite energy and finite average power or power signal. That is, E is equal to infinite and power P is greater than 0 but less than infinite. Signals that do not satisfy these two conditions are neither energy nor power signals. Mostly all periodic signals are power signals and all aperiodic signals are energy signals. Okay, check whether the given signal is energy or power signal. X of t is equal to k into e power minus at u of t, where a is finite and k is a constant. A is positive, right? So first we can compute the energy of the given signal. That is E is equal to limit of t tends to infinite integral minus t2 plus t x of mod squared dt. X of t is k e power minus at u of t. Since u of t exists, u of t is a unit step function which has the value as 1 from 0 to infinite. So the limit from minus t2 plus t is converted into 0 to t. So, and x of t is equal to k e power minus at. So x squared t is equal to k squared e power minus 2at into dt. Here k squared is a constant, so you can take outside the integration. So integral of e power minus at is just equal to e power minus at by minus 2a. Then you apply the upper and lower limit. So if you apply the upper limit, it will become e power minus a 2a capital T. Lower limit is 0, so it is e power 0 which is equal to 1. So after subtracting, you will get k energy E is equal to k squared divided by 2a under the category of t tends to infinite, because here we will get e power minus 2at in the numerator. So if you apply the limit as infinite, e power minus infinite will become 0. So you will get 1 by 2a. So the energy is equal to k squared by 2a, where k is a constant and a is also finite. So energy is finite. So the given signal is an energy signal. Similarly, we can take the another example which is discrete in nature. So check the given signal is energy or power signal, where x of n is equal to k a power n u of n. Here a is finite, positive, and k is a constant. The energy E can be calculated by using the equation limit of n tends to infinite summation n is equal to minus n2 plus n x of n mod squared. Since u of n exists, the limit is from minus n2 plus n is changed into 0 to n, and the value for x of n mod squareds are nothing but k squared a power 2n. Since a is less than infinite, if you assume a is less than 1, if you assume like that, a is a fraction, then k squared is a constant, so you can take outside, and a is less than 1, then you are using geometric progression. The summation from n is equal to 0 to capital N, applying the limit of n tends to infinite, can be treated as summation n is equal to 0 to infinite a power 2n. Using GP, this can be written as 1 by 1 minus A. Therefore, the energy E is equal to k squared divided by 1 minus A under the condition that A is less than 1. Since the energy of the given signal is finite, the given signal is an energy signal. Now we can say take another example. X of t is equal to k u of t. The normalized energy E is equal to limit of n tends to infinite minus t2 plus t x of t mod squared dt, which is equal to x of squared is replaced by k squared. Since u of t exists, the limit is changed to 0 to t. So k squared is constant, so you can take outside the integral. So integral of dt gives only t. So applying the upper and lower limit t and 0, will get k squared into t. So if you apply the limit as t tends to infinite, your energy will become infinite. Then the average power of the signal is calculated by using the equation, that is 1 by limit of t tends to infinite 1 by 2t integral minus t to p t x of t mod square dt. Here x of t mod squared is replaced by once again k squared. Since u of t exists, the limit from minus t to plus t is changed into 0 to t. So k squared is constant, so you can take outside the integral. So integral of dt gives t. Applying upper and lower limit, you will get k squared t by 2t. And applying the limit as t tends to infinite, t will get cancelled. So the term is independent of t, right? So we'll get k squared by 2. That means since the given signal has infinite energy and average power is 0, average power is constant, then you can say that the given signal is a power signal. Good to know here is energy and power signals are mutually exclusive signals. Periodic signals or power signals. However, all power signals need not be periodic signal. Aperiodic signals are energy signals. Causal, non-causal and anti-causal signal. Signals that are zero for all negative instants or non-zero values only in the positive time or instant are called causal signal, while the signals that are zero for all positive time or instant are non-zero only in the negative instant or time are called anti-causal signal. A non-causal signal is one that has non-zero values in both positive and negative time or instants. Here figure A shows the causal signal because it exists only positive instances, and B gives non-causal signal because it has non-zero value both positive and negative instances. And figure C shows the anti-causal signal because the signal exists only in the negative time period. Check whether the given signal x of t is equal to u of t minus u of t minus 8 is deterministic or random signal, even or odd signal, periodic or aperiodic signal, energy or power signal, causal, non-causal or anti-causal signal. The solution. First, here u of t represents unit step function which has a value as 1 from 0 to infinite, 0 otherwise. So x of t is equal to u of t minus u of t minus 8. So here, since this given signal is well defined for the whole period or whole the instant from minus infinite to plus infinite, therefore the given signal is a deterministic signal. To find the even or odd, whether it is even or odd, x of t is this. If you substitute t by minus t, you will get x of minus t is equal to u of minus t minus u of minus t minus 8, which is also equal to x of t. Therefore, the given signal is an even signal. X of t is equal to u of t minus u of t minus 8. Substituting t by t plus capital T, we'll get x of t plus t is equal to u of t plus t minus u of t plus t minus 8, which is not equal to x of t. That means the given signal is not a periodic signal. It is an aperiodic signal. Next, find the energy of the given signal. Energy is equal to limit of t tends to infinite integral minus t to plus t x of t mod square dt. So u of t is unit step function which has a value as 1 from 0 to infinite, and u of t minus 8 as a value as 1 from the instant 8 to infinite, 0 otherwise. So the first term is replaced by the integral limit with 0 to infinite, and the second term is replaced with the integral limit as 8 to infinite. So if you integrate with respect to dt, we'll get t. for both terms. So for the first term, the limit is 0 to infinite. Second term, the limit is 8 to infinite. So you'll get infinite minus 0 minus infinite plus 8. That means the final result, infinite will get cancelled. So the finally will get 0, infinite plus infinite minus 0 minus infinite plus 8. So infinite will get cancelled. So finally you'll get 8, which is independent of t. So you'll get E is equal to 8. That means the given signal is an finite energy signal. U of t minus U of t minus 8 both exist only from the instant positive instances. So it is called causal signal. Here there are some 6 number of problems are given. Just find out whether the following signals are deterministic or random, periodic or aperiodic, energy or power signal. Okay, or neither energy or nor power signal, right? So the first example, unit step function. So it is under deterministic because it is well defined. It is deterministic and it is not random and it is not periodic. It is an aperiodic signal and it is having finite energy power and energy is it is not energy signal and it is not neither energy nor power signal. So if you see here we'll find one thing, right? Because it is aperiodic but it is under power signal, right? So already we discussed all power signals need not be periodic. That is proved here. Next, for submission B, that is x of t is equal to r of t minus 5. This is also under ramp. R of t is a ramp which is well defined for an instant from 0 to infinite. So x of t is deterministic signal. Yes. It is not random. No. Right. Periodic. Whether it is periodic? No, it is not periodic. It exists only for finite time interval. It is not repeated. So it is under aperiodic. And it is neither energy nor power signal. Right. And for C, it is also in terms of unit step and ramp function. So x of t is well defined. So it is deterministic. It is not random. And it is aperiodic. And it is neither energy nor power signal. And x of t is equal to e power minus 20t. It is also well defined. So it is under deterministic, not random, and it is under aperiodic signal and it is under energy signal. And cos 20 pi t plus cos 80 pi t. So 80 by 20 is a fixed value. So the sum it is well defined for a period of minus infinite to plus infinite. So it is under deterministic and it is periodic and it is a power signal. And for F problem, it is also well defined, but it is one term is aperiodic, exponential is aperiodic, and cosine is periodic. So since it is well determined, it is under deterministic signal. Since it is the sum of periodic and aperiodic signal, so the resultant is aperiodic signal, and it is fine. It has finite energy and finite power. So sum of these two will resultant as power signal. Thank you for listening.